Find the volume of the solid bounded above by the graph of f of x comma y equal to x, y, sine, open parentheses, x squared times y, close parentheses, and below by the xy plane on the rectangular region R equal to the interval from 0 to 1 by the interval from 0 to pi. Let's set this integral up as v, volume, is equal to the integral from 0 to 1 with respect to x of the integral from 0 to pi with respect to y of the function x, y, sine parentheses, x squared, y, close parentheses. To take the antiderivative with respect to y, this requires integration by parts, and I will leave that to you so that you can double check your steps. Applying integration by parts one time, one iteration of that, this volume is equal to the integral from 0 to 1 with respect to x of a fraction with a numerator of negative y cosine, open parentheses, x squared y, close parentheses, and a denominator of x, end fraction, plus a numerator of sine, open parentheses, x squared y, denominator of x cubed, end fraction. That function evaluated from 0 to pi, and then finally our integral is with respect to x. Evaluating from 0 to pi causes our integral to become integral from 0 to 1 of, or with respect to x, my function is first a fraction with a numerator of negative pi cosine, open parentheses, pi x squared, close parentheses. Then we have a denominator of x, end fraction, plus numerator of sine, open parentheses, pi x squared, close parentheses, and a denominator of x cubed. Now I need to change one thing about the limits on my integration, because at this point this new function, this new integrand, is undefined at 0. And so I'm going to change this into a limit. Okay, so I'm going to change my lower end point to be a b, and outside, applied to this whole integral, I'm going to have a limit as b approaches 0. And specifically it's from above, but now the antiderivative of the new inner function requires integration by parts. Again, each of those two terms, I believe, will require one step of integration by parts. So my volume is equal to the limit as b approaches 0 from above of the function numerator negative sine, open parentheses, pi x squared, close parentheses, the denominator of 2x squared, end fraction, that evaluated from b to 1. So this is going to be equal to the limit as b approaches 0 from above of a fraction with a numerator of sine, open parentheses, pi b squared, close parentheses, and a denominator of 2b squared. Now this limit all on its own does not exist, but if we apply L'Hopital's rule, this will be equal to the limit as b approaches 0 from above of a fraction with a numerator of 2 pi b cosine, open parentheses, pi b squared, close parentheses, with a denominator of 4b. Now this reduces to equal the limit as b approaches 0 from above of pi over 2 multiplied by cosine, open parentheses, pi b squared. And if we take that limit, this will be equal to pi over 2. And so our volume of that region, bounded above by f of x comma y and below by the xy plane, is equal to pi over 2.